Okay, so when it comes to software, there are many different vulnerabilities in here. I've just shown a few here that relate to memory management, where it might be possible to subvert some of the management controls because you have protected areas of memory, and unprotected it may be possible to release the protection on areas of memory. It may be possible to scrape the RAM as it's running and reveal secrets like passwords and keys and so on. And a major problem is around the updating of the firmware and also the secure enclave. So in here we will have our private keys, which will be used to sign things. If someone was able to get access to that, then they could reveal the private keys that were used. And especially if this is a root of trust for other devices, it could compromise a whole network. When we get firmware, we need to be able to check that it's a valid firmware. So we would check the digital signature on any updates using the key that was the private key within the secure enclave. So a lot of these threats are related to the updates that we would have. Often we run containers within Docker, and we might be running a hypervisor with virtual machines. Someone could try and escape the container and go straight into the hardware or the operating system. Along with this, same thing can happen with a VM instance. It may be possible to bypass the hypervisor and go into the machine. But a general problem with hypervisors is when someone can get access to that hypervisor layer and can actually infect the virtual machine with bad data. Then we can get rootkits for our operating systems. And obviously the boot process of the system needs to be secure to make sure that someone cannot interfere with that boot process from the BIOS.